Welcome back. In this video, we'll be resolving this simple network. Here we are asked to find the equivalent resistance in this network. So first thing we have to take note is that to solve this, we're going to look at this direction of the equivalent circuit. Obviously, it is open. So looking inwardly, we'll start from the last resistance here. So we'll look at this last loop. When we are able to resolve the resistance in this loop, then we start reducing the circuit till we have one single resistance. So basically, first and first is to look at this last loop. Of course, this 4 ohms resistor, the 5 and the 3 ohms here are all in series. So to resolve that, is going to be 4 plus 5 plus 3, which is going to give us a total of 12 ohms. So redrawing this circuit, what we now have in place of these 3 resistance, we have just this 12 ohms resistor. So we'll complete the other parts of the circuit. Here we'll still have 4 ohms. Then we have 3 ohms here. We have 6 ohms here. Next we have 2 ohms. Finally, we have this 1 ohm resistor here. So moving forward, now we have 2 resistors in this last loop here. So you can see that the 2 resistors are in parallel. So the next thing you have to do is to resolve these 2 resistances. So it is 4 parallel 12. And remember, to resolve resistors in parallel, we do R1 times R2 over R1 plus R2. So in this case, what we have is what? 4 times 12 over 4 plus 12. If you do that simple calculation, we should have 48 divided by 16. So sorry, what we have here is 12. Okay, so I'll just clean that out. So I'll just clean that out. So this is 12. Okay, so I'll just clean that out, and what we have now is 4 plus 2, 16, and this should give us 3 ohms. So I'm going to take that ohms, then we'll plug it back into this circuit. This circuit becomes somewhat like this. This is our 2 ohms, this is our 3 ohms. So in place of these 2 resistance, now we have 3 ohms, and this will close up. Then we have 6 ohms here. Okay, so we have 1 ohm. This is our new system. Sorry, this is ohms. So you can see this is also in series with this, so we can resolve that to give us 3 plus 3, total of 6 ohms. So what we have next now is 2 ohms here, 6 ohms here, another 6 ohms. This is the sum of these two. And then we have 1 ohm here. So what we need to do now is to resolve this. 6 parallel 6 will give us 6 times 6 all over 6 plus 6, which is 36 all over 12. That will give us 3. So with this new value, we resolve this. This will give us 2 ohms, 3 ohms, then 1 ohms. So this gives us the final one, which is now 2 plus 3 plus 1, total of what? 6 ohms. and that is the final resolution. So basically what we did here is, first of all, look at the entire circuit, resolve the last one into 12, resolve these two in parallel into 3, reduce to this, resolve these two into 6, and now we have here, resolve this into 3. That will give us the final stage.